Hello everyone, thanks for tuning in to the second update for the winter of 2017-2018. So we began the winter updates for another season last week, a week ago today, did the first update. Seemed to go down quite well, quite an interesting update. We went through looking at various things that will eventually become part of the winter 2017-18 forecast. So looking at things like sea surface temperature anomalies, what's happening in the Atlantic Ocean, in the Pacific Ocean, what's happening in terms of ENSO. Also looking at hurricane activity, Mercubio, quasi-biennial oscillations, solar activity, and other things as well. We're going to have an update on all of those things for today's second update. And we're going to begin where we left off with last week's first update. So we looked at some analogues for last week's first update in terms of summer conditions, front-loaded summers, so summers that were warmer in the early part of summer and then became cooler as the summer sort of progressed. So for this second update, we're going to continue with that idea, but instead of looking at temperature, we're going to look at summers that were front-loaded in terms of high pressure. Doesn't necessarily follow that high pressure in early summer is going to be warm. So we have to separate these two out. There will be a little bit of overlap with some of the years in terms of the warmer early summers, front-loaded summers, and the summers that are high-pressure dominated. But by no means all of those summers. In fact, most of them are going to be unique summers in their own right. And of course, this is looking at what happened in the winters that followed those front-loaded summers. So I'll talk you through those analogues in a second. Before I get on with that, just to say that this could be quite a long video, so you can't watch it all in one go. Don't worry, it will be kept at website indefinitely, so you can come back and watch this video whenever you want. It'll be placed on the winter updates and forecast page later on today, probably around 6-7 o'clock. I'm usually a little bit late with it, but I will get it up later on today, and you'll be able to watch the video on the winter forecast and updates page and read the written report that goes with it as well. Sometime this evening, and then it'll be kept at the website indefinitely, so you can't watch the video in one go. You'll be able to come back and watch it whenever you want. Right, we better get on with the second winter 2017-18 update. Let's get right tab up. So I'll just go through where we left off, okay, with last week's analogues. So we looked at analogues last week that were front-loaded summers in terms of temperature. So temperatures that were warmer in the early summer period and then became cooler as the summer progressed. There were 13 of those summers, and this, when we combine all of those summers together, this was how the all years combined chart looked for the winters following those summers. So we start at the winter of 1896, 1897, just there, and we finish up with winter of 2014, 2015. Putting all of those winters together, following those warm front-loaded summers, we come out with a very unsettled signal. I have to change the colour of the highlighter, so we come out with a very unsettled signal. It is a signal for really unsettled winters. We have got a bit of northern block here around Greenland with these summers, but we're doing something a bit like that with the flow and with the jet stream. So there are some, or there were some colder winters included in that analogues package, but generally, mainly, actually, it's just a very unsettled signal for the winters that follow those sort of front-loaded summers from a temperature perspective. Now, we have 13 of those winters for the first analogues package last week. We've got 32 winters. So over double for this analogues package. So clearly front-loaded summers from a high pressure perspective, more common than front-loaded summers from a temperature perspective. So the first winter we're going to start off with for this analogues package is the winter of 1874-1875, following the front-loaded summer of 1874 from a high pressure perspective. And by the way, all of these analogues that you see, not just in this video, but in all of the winter updates, they're all coming from our good friend James at Krill. So a big thank you to James, as always, for getting these analogues together for us and providing us with all of this data and all of this information. Really couldn't do these updates without James's input, so a big thank you to James for that. I know James is going to be watching, so thanks so much, as always, James. Right, we're going to go on with the analogues, and we begin with winter of 1874-1875. This one looks quite blocky, actually. We've got above average heights up to our north, and then we've got below average heights down to our south and to our southeast. And it does actually look like it would have been quite a cool winter at the very least, maybe even pretty cold. So quite a cold winter to start us off for today's analogues package. Then we go through to winter of 1876-1877. This one looks very, very unsettled. A really deep trough in the Atlantic. It's an Atlantic onslaught, really bringing the flow and the jet stream across the Atlantic. That would have been a very, very wet winter, probably fairly mild. It's a really Atlantic-driven winter, but the main thing would have been a lot of rain in the winter of 1877. 1886 is our next winter, so 1885, 1886. This one looks cold. We've got above average heights in the Atlantic, and we've got below average heights centering to our south and to our southeast. There's a bit of an Atlantic influence, but overall it looks like we're on the cold side of the jet, so that looks like a pretty cold winter there for 1886, following the front-loaded summer of 1885 from a high-pressure perspective. The next one looks quite interesting as well. This is 1888, so the winter of 1887-1888. We have above-average heights out in the Atlantic and to the northwest of the British Isles, with below-average heights to the south and to the southeast. We'd be pulling in the flow like that, so another cold analogue there for 1888. Bear in mind, these are a very long time ago. The climate now is very significantly different to what it was in Victorian times, but sometimes it is useful to go back and look at these very old winters from a really long time ago. Our next winter is 1890, so this is 1889 to 1890. This one looks like a pretty cold winter as well, because we've got below average heights up to the northwest, but we've got this large ridge here centering over Scandinavia, so we probably have been pulling in some pretty cold east to southeasterly winds there through the winter of 1889. 1890. I'm not sure it's tremendously cold winter, that one. Probably pretty dry and very different actually as a pattern to anything that we've seen so far. But there would have been some cold conditions in with that, I'm quite sure. Then we go through to 1895. This is a severe winter turning up within this analogues package. So these early analogues look very, very interesting, don't they? For winters following high pressure dominated front-loaded summers. This one has lots of ridging out to the north and to the northwest of us, with below average heights down to the south and southeast. And yeah, we'd have been doing something a bit like that with the flow, with the jet stream. That was a severe winter, the winter of 1894, 1895. Very interesting to see that one turning up in the analogues package. 1896 is our next one. This one looks very different. This one has above average heights extending through the Atlantic into the UK. Would have been quite a lot of dry weather with that, and I'm not sure it's particularly cold. Would have been doing something a bit like that with the flow. Just very dry. Bearing in mind this is Victorian here, so there probably would be a lot of fog, a lot of smog in with that winter of 1895, 1896. So that would have had a dampening effect on the temperatures. If that kind of pattern occurred now, I suspect that would be a relatively mild, but also probably very quiet winter. The next one, not quite as interesting either. This is 1898, again high pressure very close to us, this time centre perhaps a little bit more to our south. So this is a definitively mild winter. We're bringing the flow and the jet stream in like that with low pressure up here. That's an Atlantic driven winter, albeit fairly dry down in the south, but probably unsettled in the north. It is zonal. 1904 I should say is our next one. This takes us back to being very unsettled, so not overly cold, but just a really deep trough here around the UK and much of Western Europe, doing something like that with the flow and with jet stream. The main thing about that winter is that it would have been very unsettled, very wet, lots of heavy rain coming in from off the Atlantic in the winter of 1903, 1904. 1904, 1905 is next. Again, above average heights out to the west. So that's a little bit of a semi-recurring theme here. Doing something a bit like that with the flow and with the jet stream. That's a very quiet winter, Probably some cold snaps at times from the north, but generally not remembered as a particularly cold winter. 1915, 1916 is next. This one just looks very unsettled in terms of reanalysis. That was a very odd winter, had a really cold November, had the mildest January on record in 1916. I mean, it turned very cold at the end of February and had a really cold March as well. So very odd winter in 1915, 1916. As the reanalysis for the winter as a whole, from December to February, it just looks very unsettled. And bear in mind, there's an exceptionally mild, record-breakingly mild January in with that. And we go to 1920, and this one also looking generally mild and zonal, so lots of low pressure up to the north, high pressure to the south, bringing the jet stream through like that. That was a very mild winter of 1920, after a very cold autumn in 1919. 1922 is next, another mild winter. So it appears now that after those cold earlier winters in the 1800s, now we're going to a milder, more zonal type winter setup. So this one has lots of low pressure to the north and the east of the country, and we're doing something like that with the flow on the jet stream. It was a mild winter of 1921, 1922. 1924 is next. This one looks a little bit more interesting. Don't know much about winter of 1923, 1924, but we have got some above average heights to our north with below average heights to the south. So at the very least, you would think that would have brought in some cold snaps. There weren't many cold winters at all through the 1920s and 1930s. But that perhaps was a little bit more interesting winter of 1924. 1926 is next, and this one just goes back to being very Atlantic driven. So this one looks very wet and also pretty mild, I would have thought, with the flow from the west, from the southwest too. Real mixed bag here with these winters following front-loaded, high-pressure dominated early summers. So this one, 1932, we're going back to high pressure. And we have a big ridge here centred around the UK. Just a very quiet winter, I would have thought, that one, and probably reasonably mild. I'm just going to take you back to this winter, 1925, 1926. I forgot to say that this one actually matches, overlaps, I should say, with the winters that we was looking at in last week's analogues package. So not only is this one front-loaded from a high-pressure perspective, it's also front-loaded from a temperature perspective. So maybe this one is a little bit more important out of all of these analogues. The winter of 1926 is our first one that is kind of overlapping with last week's analogues. 1935 next, and winter of 1934, 1935. This looks quite unsettled. We've got below average heights centering to our east, above average heights up to the north. Again, don't know a huge amount about this, but I think December 1934 was one of the mildest Decembers on record. 1942 next, and this one is different again. This one has lots of above average heights to the west and to the north of the country. So very quiet winter, but also really cold. We've been doing something like that with the flow, with the jet stream. This was another one of those severely cold early 1940s winters. There was 3 of them in a row, 1940, 1941. The last one was 1942. So we've got another pretty severe winter there showing up within the analogues package, albeit from a very different pattern compared to anything that we've seen before. 1944 is our next winter. This one has above average heights to our west, and doing something like that, the flow of the jet stream, generally very quiet and also reasonably mild. There wasn't much way of cold weather in winter of 1944. 1953, next this is 52, 53, and this one has above average heights out to the west, to the northwest, with below average heights to the south and the southeast. Now, if you watch the historic video that we released on Bank Holiday Monday, you'll know, back in August, you'll know all about winter of 1952, 1953, but it was a pretty cold one, actually. There were regular cold snaps, and also very stormy winter as well, which you may not think from looking at that reanalysis, but it was a very stormy winter at times in 1952, 1953. This is our next overlap winter, 60-61. This was front-loaded in terms of the summer, in terms of both temperature and also precipitation, in terms of temperature and pressure as well. So both these years, 1925, 1926, 1960, 1961, they're front-loaded from both front-loaded summers from both temperature and pressure perspective. So again, this is another pretty important winter. 1960, 1961, below average heights out to the west, and yeah, we're bringing that flow and the jet stream through. Looks a very unsettled and reasonably mild winter too. 62 is showing up, 1961, 1962. This one kind of precedes the severe winter that occurred in the following winter. This one with above average heights to the west, below average heights to the east, and bringing the wind down from the north. At times, there was some cold weather during this winter 61, 62. Kind of beginning to set the scene for what was going to happen in the next winter. 1967, 1968 also looks quite interesting. We've got to these 1960s winters, and they are a little bit more interesting. This one has above average heights, high pressure to the northwest, below average heights to the east. Again, we're pulling the wind down from that kind of direction. That one looks pretty cold at times, winter of 1968. Then quite a long gap, interestingly, to 1980, so we don't have any years in the 1970s. This one is an odd winter. It has lots of above average heights to the north, which you would think is going to be quite a cold winter, but then we've got this area of below average heights coming in across the UK underneath, and it's generally quite a mild winter, actually, winter of 79, 80, with high pressure down here. Quite a bizarre winter, that one. 1987 is next. We know all about winter of 1986, 1987. This is the reanalysis for the winter of 1987, with above average heights to the north, and pulling in that easy wind. We know there was a very cold spell, specifically focused on January 1987. Otherwise, not overly cold, really. December 86 was mild, and February 1987 wasn't overly cold either. It got really cold again in March. 1990 next, 89, 90 looks like this. It's very zonal sort of winter, low pressure dominated, really mild and wet. The winter of 1990. So a real mixed bag here with these winters, quite interesting. 1992, 1993 is our next year. This is another overlap. This is the third one that is overlapping, both in terms of temperature and pressure from a front-loaded summer perspective. This one, very quiet, lots of high pressure around above average heights close to the country. So just a really quiet, benign, and generally fairly mildish winter of 1992, 1993. 1994, 1995 is next. This one is another mild 1990s winter. So this one is very zonal. We've got high pressure to the south, low pressure to the north, and bringing this mild southwesterly flow through. The winter of 1994, 1995 was a very mild one. Then we've got 2000. So this is 1999 to 2000, and this one has below average heights to the north, above average heights to the south, to the southwest. It's another late 1990s mild winter. Our next winter is 2006-2007. This is our next overlap. This is our fourth overlap in terms of temperature and precipitation. So again, another fairly important winter, this one. And again, notice this one's another mild one. As we're going along, I think what we're seeing is that the winters are getting milder. That may be because what happens after these front-loaded summers is changing, or it could just be down to the fact that the climate overall is changing as we're getting more and more towards the modern era. So anyway, this one is another mild one, the winter of 2006, 2007, bringing the flow in like that with high pressure to the south and low pressure to the north. However, we get to winter of 2010, 2011. This is another overlap winter. This one appeared in last week's analogues package as well. And what do we see? We see above average heights up to the north, below average heights down to the south. and doing something like that with the flow overall. Now, we know what happened in this winter. We had the December to remember in 2010, when it turned significantly milder as we went through into February 2011. But we did have that big freeze up in December 2010. And then finally, we come to our last year, which again is another overlap year. So it appears that the front-loaded summers from temperature and pressure perspectives get more frequent as we get closer to the modern era as well, quite interestingly. Our last winter is 2014-2015, this one following the front-loaded summer of 2014, of course, from both a temperature and pressure perspective. This one was quite a mild winter, close to average temperatures really. We had below average heights to the north, above average heights to the south, so familiar setup, just that the jet stream aligned a little bit more northwest to southeast, which was slightly cooler winter for that one, with temperatures coming out near normal. Now, if we put all of these together for the pre-1950s winters, this is what we come out with for all years combined. Looks an unsettled sort of scenario. It does look potentially fairly cold as well. We do have some above average heights out to the northwest. We've got below average heights to the southeast. Also hints of a bit of a Scandinavian ridge as well. So it does look unsettled overall from these winters. We know there's a lot of variation between them, but overall does look quite unsettled. But also looks potentially a little bit cold as well with the all years combined chart pre-1950. Post-1950, it just looks very unsettled. This is how it looks post-1950. So this is taking us from 1953 down to 2015. And you notice the above average heights are centred to the southwest, with below average heights up to the north, to the northeast. And it's Atlantic driven, and overall it's generally quite mild as well. So there is quite a significant difference actually with these analogues. From the pre-1950 set to the post-1950 set. As I say, that might be just down to climate change, the way that the climate has changed as we've gone closer and closer to the modern era. It could also be that there's so much randomness within these analogues. You'll notice that as we've looked at these, there are many different scenarios, many different options on the table. Could be that the sort of different scenarios that are being thrown up just aren't all that reliable. But either way, quite interesting that actually a front-loaded summer from a high-pressure perspective and a front-loaded summer from a temperature perspective, certainly post-1950, does look a very unsettled scenario for the winters that follow. So that's the analogues in terms of front-loaded summers done, and now let's move on to the rest of the update. And as I say, a big thank you to James as always. We're going to have a look at the oceans next, but before I do that, I may just go and get myself a drink of water. Why don't you go and get yourself a cup of tea and a couple of biscuits, and we might meet back here for the second sort of part of the second winter update in a few moments. I'm going to go and give my throat a bit of a rinse, I think, so see you in a few minutes. Okay, and welcome back. Hope we're all suitably refreshed and ready to go for the second part of the second winter 2017-18 update. We've dealt with all the analogues in the first part of the video. Now we're going to move on and have a look at the rest of GavsWeatherVids methodology. We're going to have a look at sea surface temperature anomalies, first of all, in terms of the Atlantic and Pacific Ocean. So this was the position when we did the first update last week. We used this chart from NOAA from the 31st of August. There's three areas that we're specifically interested in. We've got the ENSO region over here. We've got the Northern Pacific Ocean up here. And then, of course, we've got the Atlantic Ocean over there. That's how things looked last week. Let's concentrate on ENSO region first of all. So we'll go through to the latest image from NOAA, which was generated on the 7th of September. And look at this, we have further strengthening of those cold sea surface temperature anomalies through the ENSO region. So that was situation on the last day of August. This is the situation now. And definitely these blue colours here through the equatorial Pacific Ocean are getting deeper. So this has been an ongoing trend, particularly through August, that it appears that we are rather unexpectedly increasingly moving into a La Nina type scenario, and I'll have more on this for you next week when we get some more of the longer range models updating. The CFS V2, which I showed you last week, is going for a weak to moderate La Nina now for the winter of 2017-18, and we'll see next week whether any of the other longer range models are coming on board. But just from seeing what's happening in the ocean, it does appear that week by week we are shifting more and more towards at least a weak La Nina for the winter of 2017-18, if not maybe on something even a little bit stronger than that. And I think actually next week's third update is probably going to focus on analogues in terms of ENSO, so in terms of either ENSO neutral or possibly weak La Nina winter. So that'll be coming up for you for next week's third update. James has already been beavering away on that. Further north in the Pacific Ocean, again, that situation last week, this situation now, it appears that we are cooling down close to Alaska. This is normally quite a cold area, albeit underneath it, it's fairly warm. Be interesting to see whether that's going to cool over the coming few weeks. In the Atlantic Ocean, again, we don't appear to be all that far from a tripole, so we've got a fair amount of warm sea surface temperature anomalies to the south of Greenland. We know that the tropical Atlantic is warm as well, so it's warm there, it's warm there. What we need to do in this area is start getting it to go colder, but if we did that, we wouldn't be all that far from a tripole. So from an ocean perspective, things are looking quite interesting at the moment. We'll need to keep an eye on it. Tying in with the oceans, of course, particularly the tropical Atlantic Ocean, is the hurricane season. So we've had a lot of activity in the hurricanes, in the hurricane region, in the tropical Atlantic, over the past week. This is the 2017 Atlantic Hurricane Season page from Wikipedia, and we'll just scroll down and see what the scores on the doors are so far. Up to the 9th of the 9th, 17, we've had 12 total depressions, we've had 11 storms, we've had 6 hurricanes, we've already had 3 major, which is category 3 or above, hurricanes. And it's still pretty early, really, because the hurricane season continues to be in its peak through the remainder of September and into at least the middle of October as well. So probably got another 4 to 6 weeks of peak activity to go. Those numbers are already looking really quite impressive. Remember, the idea behind why we're looking at hurricanes is that a hurricane is distributing heat from the tropics into the mid-latitudes and eventually taking it into the pole. If you get lots of hurricanes dumping lots of heat into the pole, then it can have an effect later on in terms of blocking over the North Pole. So that's one of the reasons that we have been looking at, or that we look at hurricanes in the winter updates. We have 3 areas of interest over the past week, of course. It's from the National Hurricane Center. We've had a hurricane near Mexico. We've had the main event, which is Irma, of course, producing devastating weather through the Caribbean, and now as you're watching this, producing devastating weather into Florida, and also Hurricane Jose. The way those 3 hurricanes have lined up hasn't gone unnoticed, because actually what happened in 2010 around the same time of year was very similar. So this is comparing the 3 hurricanes this year in 2017 with the 3 hurricanes in 2010. So this is showing Katia over here near Mexico. We've got Irma, of course, there through the Caribbean, and then we've got Jose over in the tropical Atlantic. That's from the 7th of September 2017. This is from the 16th of September 2010. It's the same idea, even interestingly, with the same sort of letters for the names. So instead of Katia, we've got Hurricane Carl over here next to Mexico. And then instead of Irma, we've got Iga here heading towards the Caribbean. And then instead of Jose, we've got Julia out in the middle part of the tropical Atlantic. But it's very interesting how they do look really similar in terms of a tripole, if you like, or a trilogy of hurricanes or storms that we see in 2017 and also repeated in 2010. Really quite interesting how that's happened. Probably no more than coincidence, but it certainly hasn't gone unnoticed on many of the forums and on social media as well. This is the Wikipedia page for the hurricane season of 2010, by the way, and you go right way back to the 1800s with these Wikipedia pages. They're always really interesting to look at. So the hurricane season of 2010 shaped up like this. It had 21 depressions in total. It had 19 storms, had 12 hurricanes, and it had 5 category 3 or above, so major hurricanes. So it was a big season, hurricane season in 2010, as was 2011 and 2012 too. And we know that after the big hurricane season of 2010, we got the December to remember in December 2010. As I say, that's probably no more than coincidence. I don't think we can read too much into that in terms of our winter fate, in terms of the trilogy of storms in those 2 years. But it is interesting how they line up like that. And at the very least, what we should be looking at, I think, is that we're having another pretty big hurricane season, which could have implications for more blocking this winter. Right, going to something completely different, solar activity next. This is the latest disk. This is the latest image on the solar disk from our side of the disk today from solarham.net. And we've got quite a lot of sunspots. Sunspot activity, solar activity is officially designated today as being at moderate levels. But actually, a few days ago, we was at high levels. I'm going to show you the solar tracker, which has been sent through by our good friend James Ackrill. And look at this. This is the GavsWeatherVids Winter Update Solar Activity Tracker, updated to the 9th of the 9th, 17. And I want you to just look at this spike in activity that has occurred in the past week. So a couple of days ago, we was up at that level, an incredible level of solar activity. That is either high or very high levels of activity. And look how the trend lines have shot up, indicated by the thick green, the thick red, and the thick pink lines. They are our trend lines, and really shooting up there that we see over the past week. So we have had a huge increase in solar activity. James has actually gone back with this and tells me that the last time we was at this level of sunspot activity, or solar activity, was back in February 2016. Now, we are very late in the season. That's what's quite interesting about this, because you wouldn't really be expecting that we would drop, that we would go up to such a high level of sunspot activity as we see there. When we're so late in the season, we're probably only around 18 months from solar minimum. But James has been looking at this a little bit, and I'll have more of it in subsequent updates, because this spike in activity is very interesting. But it may be, I don't want to give too much away for subsequent updates, but it may be that this is something that happens when we have very weak solar cycles overall. So we know that the current solar cycle, 24, has been a very weak solar cycle, certainly in terms of sunspot numbers, and historically, compared to most of the solar cycles that we've been through, right way back to number 1, we know that this one has been a very weak solar cycle compared to most other solar cycles. And James, I think, he's still doing research on this, but I think it's possible that a late spike, a late surge in sunspot numbers is something that can happen when you have weak solar cycles. But we will have more on this for you in future updates. The trend lines now, or I should say the trend lines, they're not moving down yet, but the actual sunspot numbers are now beginning to shift downwards. You would expect a collapse, really. We should be seeing by next week's update from here we should be down back to this sort of level. It'd be very interesting to see where the tracker goes next week. But some really interesting developments in terms of what's happened on the sun over the past week. You certainly wouldn't want to be seeing that sort of a spike in the middle of winter, because that would reduce the chance of northern blocking quite substantially in the winter. Right, we're going to have a look at Russian/Siberian snow cover and Arctic sea ice next. So let's deal with snow cover first of all. Still not much to be seen. You wouldn't expect it yet. It's very early. This is more something that we focus on in October. But interestingly, we have got a few white patches appearing here in the eastern part of Siberia. That's quite early, actually, to be seeing that. So maybe we might be seeing indications that we're going to fill up the Siberian plain quite quickly again this season. But it's really too early to say that. And in fact, over the next week or two, we might see some of these white patches melting a little bit. Wouldn't totally rule that out. Further north, this is how Arctic sea ice is looking. So again, we have had another big melt season. We know that from last week's first update. This is where we still have Arctic sea ice remaining. So it has been another pretty big melt season. All this blue here is where the Arctic sea ice has melted. Let's see how things are looking in terms of the graph here from the website Arctic Sea Ice News and Analysis. This is the interactive sea ice graph. So this is our long-term trend line just here, this thick grey line. We go right way back to 1979 with this. It's showing the minimum extent of Arctic sea ice for every year back to 1979. So I'll just show you 1979, and that was it. That blue line just there saw a minimum Arctic sea ice extent of that sort of level. Let's put in the latest year, 2017, and that's it. You can see how much lower we are in terms of Arctic sea ice loss in 2017 compared to 1979. Huge differences there. Right, we're going to have a look at every year back to 2006. So this is gradually going to fill up. So this is 2006 just here. This is 2007 just there. Bear in mind that this blue line just here, that is our current year of 2017. And I'm going to get rid of those two and we'll put in 2008. As we can see, we are now on a par with 2008, quite interestingly. That's a year that looks to be matching 2017. 2009 is there, so the Arctic sea ice extent of 2009 was a little bit above this year. Get rid of that and put in 2010. Very close to 2010. So 2008, 2010 appeared to be the 2 years we're closest to. 2011, another year that we are obviously very close to as well. Then we're going to go to 2012. That's the death spiral. Look at that. Obviously, we are way above now 2012's minimum Arctic sea ice extent. And we're not going to have a death spiral this year. It's a big melt season, don't get me wrong, but it isn't going to be a death spiral year. That's 2013. So I think 2013 actually had a little bit more Arctic sea ice than this year. 2014 also had more Arctic sea ice than this year. 2015, very close to 2015. So 2008, 2010, 2015 are the 2 years we're closest to at the moment. 2016, that had a very late drop in Arctic sea ice down to that level. So we're probably going to come out above 2016 when it's all said and done. Probably got about another week left of Arctic sea ice melt, so we'll have a look at this again next week. So it is another big melt season. That's the key thing to take on board with this. We're closest to 2008, 2010 and 2015 as well. And then finally, the QBO, the quasi-biennial oscillation. I told you that we would have the QBO number from NOAA for August. We have got it now, and it's another negative number. So we know we're going into the easterly QBO. On this chart, the easterly QBO is indicated by negative numbers. Our last easterly QBO was in 2014. 2015, these negative numbers that you see just here. Then we had a long run of westerly QBO starting in the middle of 2015, going through the whole of 2016, should have gone into an easterly QBO in the middle of 2016, but the easterly QBO failed. So the westerly QBO continued through the whole of 2016 and into the first half of 2017 as well. So we had a 3-year QBO, westerly QBO, essentially from 2015 to 2017. However, in the summer, in June, we went negative down to -3. July went down to -10. Very quick drop into an easterly QBO through the summer. August comes out at -14.42. So the easterly QBO is continuing to strengthen. I suppose the change has backed off a little bit. The drop into the easterly QBO has backed off a little bit because we went from +8 there to minus in May to -3 in June. So that was a very big change from May to June in terms of the QBO. I mean, another very steep drop into the easterly QBO from June to July, -3 to -10. That has eased a little bit from July to August because we've gone from -10 to -14. So the rapidity, if there is such a word, of the change has eased a little bit, isn't changing quite as dramatically, but nevertheless the trend continues. I suspect what's going to happen with the subsequent months through September, October, November and December is that we'll see increasingly negative numbers appearing. So by sort of the final couple of months of the year, we should be down to around -20, something like that, which will be properly into the easterly QBO. Remember, the reason we look at the quasi-biennial oscillation is that when you have an easterly QBO, it tells you that the zonal westerlies are weakened. So an easterly QBO can sometimes, not always, sometimes be an indicator for a colder winter with a weaker zonal flow. There'll be a lot more about that in later videos as well. I can promise you that. Okay, so we've got to just over 40 minutes. I wanted to have this a little bit shorter than last week's first update. It is a little bit shorter, actually, by a few minutes, so a little bit better. Hopefully, the next updates will become a little bit shorter. Still, I realise it's quite a long time to sit and watch. But I hope you found the second update interesting and informative. There's certainly a lot to digest from this second update, so I hope you found it interesting. Right, next week's third update, we'll be focusing on ENSO. Have some interesting analogues with that, and also, of course, pondering perhaps whether we're going to be going into a weak La Nina, or maybe something a little bit stronger for La Nina as we get through to the winter. Have more on that next week. But at just around 43 minutes, I'm signing off. Remember, you can watch this video whenever you want on the winter updates and forecast page. There'll be a written summary that goes with it later on today. That's all for now, and thanks for watching.